Hi students, welcome, College Math. How are you guys doing today? Oh good, I'm doing good too. Thanks for answering this time. So we'll try a couple problems here. This is chapter 6 about factoring. So let's try these four problems. Number 1, and all these are going to be to factor completely and solve. So number 1, 16x to the fourth minus 2000x equals 0. So let's start with that one. And again, I'm sorry, before we start, I encourage you to try these on your own and check back with me and keep playing the video. Like pause it right now, do all the problems, and go through your answers, compare your answers to mine. So number 1. So we look at this first, and again, step 1 of factoring these problems is going to be to factor out any common factors. But we also want to be just a little careful too. I say that because, okay, if I factor out let's start with just an x. I'd have 16x cubed minus 2000x equals 0. I say just be careful a little bit because, yes, I could have factored out probably at least a 4, maybe even an 8 out of the entire equation. But I'm going to hold off on just a second. Why? Because if I look at this problem, and if I look at the difference of powers, like this is now x cubed and this is x to the 0. I have a strong suspicion this is going to be one of our SOAP problems, difference of cubes. And in fact, if I start, especially this number 2000 is going to be a little suspicious to me because hopefully I recognize that 10 cubed is 1000. So what would happen if I tried to make this term, the last term, 10 cubed? Well, let's factor out a 2 out of this now. So if I have 2x, 8 cubed minus 1000 equals 0. I say that now because guess what? This is definitely a difference of cubes now. I have my 8, which I know this is, the cube root of 8 is 2, and I know that this is 10 cubed. So what I can essentially say here, before I soap this out, this is going to be 2x times, I'll put here 2x cubed minus 10 cubed. So something cubed minus something cubed equals 0. Well, this is going to be one of our SOAP problems. So SOAP, we say first, same as in sign. The sign is the same here. So I'm taking out a 2x minus 10 because again it's something cubed minus something cubed. And I'm going to write here in a different color. What you're just going to have to remember here is that, here I'll put this over here, that a cubed minus b cubed is going to be a minus b times a squared plus the ab plus b squared. So the SOAP comes from, this is the same sign, this is the opposite, and this last one is always positive. I'm going to erase all that now. And again, I'm sorry, before I erase that, I say that because guess what? You got to remember that part. I'm sorry, there's no other way of remembering that except for just memorizing it. So going back to what we got here, I took out the a minus b, if you will, the something cubed minus something cubed, the 2x minus 10, and then this thing is going to be, this part is going to be 2x squared plus 2x times 10. This is like the a squared right here. This is the a times b, and lastly times b squared, and that still equals 0. Sorry, I just want to erase those check marks there. So after cleaning that up, I have, this is going to be 4x squared, this is now going to be 20x, times 100 equals 0. So now to solve, I need to set each one of these three factors equal to 0. So I have, okay, what's nice about soaping, I don't want to say what's nice, but when all three of these terms are positive here, there's going to be no solutions to 4x squared plus 20x plus 100 equals 0. There's going to be no rational solutions at the very least. So without using the quadratic formula or something like that, and we won't have to do that for this test. So I can kind of ignore setting this to 0 for now, but I definitely want to set these equal to 0. So 2x is going to equal to 0, and 2x minus 10 equals 0. Clearly in the first case, here x is going to be 0, here x is going to be 5. Yeah. And for now, we're just going to say there's no rational solutions to this. We want nice, pretty numbers. We may have some complex numbers or some irrational numbers, some square roots or something, and to solve that. But we'll leave that alone for now. So for this problem, x is going to be 0 or x is going to be 5. Easy, right? Okay, let's try number 2. Okay, so number 2, this is definitely just going to be a factoring one. Again, each term has a p, so I want to take out a p. And not only that, I can already see right off the bat that p equals 0 is going to be a solution, by the way. Why do I know that? Because here, if p was 0, I'd have 0 minus 0 times 28 minus 0, which is still 0. Minus, I can't write up there, there we go. So I know, for instance, that 0 will be a solution, but we'll get there in a second. Now I'm going to have to factor out this one here. And let's use the star method here. So I need two factors that are going to multiply to negative 56. How am I getting that negative 56? I'm going to do 2 times the last term. And they have to add up to 1, sorry, I'll put a 1 there, there we go. Here I'm always just going to put a 2p and a 2p, and that's only because it's my leading coefficient. And then I need to start thinking of factors of 56 that multiply to negative 56 and add up to negative 1. Okay, I was trying half, 28 and 2, no way. Let's see, what else? 8 and 7, oh, that's going to work. Negative 8 and positive 7 will add up, will multiply to 56 and add up to negative 1. So last step I do here is I just make whatever I can relatively prime to each other. 2p and 7 are already relatively prime. 2 and 8, let's chop them in half. I got p minus 4. And sorry, I've just divided the whole guy by 2 there. So this, my whole equation will factor to p. That was the original p, then the p minus 4, and 2p plus 7 equals 0. Here, first one, p is going to equal 0. Here, p minus 4 equals 0. So p is going to equal 4. And here 2p plus 7 equals 0, subtract 7, divide by 2, and I got p is going to equal negative 7 over 2. So for this problem, our solutions will be 0, 4, and negative 7 halves. That wasn't that bad, right? Alright, let's try the next one. Deceivingly simple, this one. I say deceivingly simple. It looks simple, but let's see what happens with this one. So first thing I notice with this one is the 12 is to an even power. So this should be a difference of squares. because it's something squared minus something squared, right? We had that a squared minus b squared, oops, is going to be a plus b times a minus b. So what is this squared? Well, that's going to be 6 squared. So this should factor to x to the 6th minus 1 times x to the 6th plus 1. Okay, I'm done, right? No, because now look at this. I have something to the 6th power. Isn't this something, again, to an even power? Isn't this still something squared minus something squared? Indeed it is, right? So this is actually going to be another difference of squares. This time it's x cubed squared minus 1 times x cubed plus 1. And now I look at that x to the 6th plus 1 up there, and I go, well, I can't add. It's not going to be a difference of squares, because difference of squares demand that there's a minus sign between them. But let's see, is it a difference of cubed? Is it something, difference of cubes we can add for difference of cubes? So is this going to be something cubed plus something cubed? Well, yeah, it's x cubed. It's x cubed. No, it's x squared cubed plus 1. So this is going to be a difference of cubes now, and it says SOAP, so same, that is, I can pull out my x squared, because again, my x squared, if I cube x squared, I'll get x to the 6th. And now this is going to be x squared squared, so that'll actually be x to the 4th, plus x, 1 times x squared plus 1 squared equals 0. Okay, I must be done, right? Nope, not yet, right? Everything I have on the right side, this guy right here is unfactorable, and that guy now is unfactorable. What do I have here? Uh-oh, man, this is going to get really nasty really quickly. I have two difference of cubes. One is the positive version, one is the negative version. So this is going to be x minus 1 times x squared plus x plus 1. That was my SOAP. Same, opposite, always positive. And now I have it here again too. But now I'm going to have x squared minus x plus 1. And now I'm going to have my original terms. X to the 4th. Ah. Not that one. So I'm just trying to get a little neater. X to the 4th plus x squared plus 1. Right, that fits, okay? Equals 0. Yikes, that got crazy. Here, let's write it again. X minus 1. Okay, let's not write it again. Let me just erase. Let me try to fit it in there a little bit better. Okay, so this all equals 0. And as I had mentioned previously here, don't worry about setting the weird part of SOAPs equal to 0. So everything I just underlined right there is not going to have, at the very least, a rational solution. So in this case, I just have to do these two, and clearly my answer, since I'm setting this whole thing to 0, is going to be -1 and +1. But the exercise here really was seeing how that factored out, and hopefully you were able to do that, because that got pretty crazy. If you could do that, you're in great shape for the test. Okay, last problem. Let's do a word problem here. A triangle has an area of 28 square meters. If the base is 2 meters longer than 3 times the height, what are the dimensions? Let's give it a try. Okay, so step 1, I always encourage drawing a picture and seeing if you could set this up. So here I have a triangle, some triangle, and here's the height of that triangle. And it's said that the height is going to be 3 times the base, or 2 meters plus 3 times the base. So if this is the base here, I know the formula for the area of a triangle is 1/2 base times the height. So let's just put in what I got here. I have that this is going to be 28, which is the area, times 1/2 the base, and we said that the height is going to be 2 times 3 plus the base. Here's what I recommend with these triangle problems. With that 1/2 there, why don't you go ahead and multiply both sides of the equation by 2. That'll cancel that out. So I have 56 equals, I'm also going to distribute the b, 2b plus 3b squared. So let's subtract the 56 over, and I'm just going to rearrange. I'm adding everything here. So 3b 3b squared plus 2b minus 56. Okay, so let me write that down again here. So I want to solve this guy. Let's try it with the star method. So we need some terms here. That what's 3 times 56? 168. Hang on. What's 3 times 56?
It's 168.
Yep, I was right. Phew. And they're going to add up to 2. Yikes. So I got to find some factors that multiply to 168 and add up to positive 2. So they should be pretty close to each other. Let's see here. 56 and 3 is not going to win. So what about 7? It's going to be divisible by 7, right? What's 168 divided by 7?
It's 24.
So 24 and 7, but those clearly don't add up to 2. Let's see if it's divisible by 14. I'm thinking there's some factor of 7 in here. What's 168 divided by 14?
The answer is 12.
12 and 14. Hey, hey, hey. Winner, winner, winner. Chicken dinner. So 12 and 14. They're going to add up to a positive number, so the smaller number has to be negative. So that'll be negative 12. And let's make everything prime. So divide this left side by 3. We got b minus 4. And I don't think 3 and 14 are already prime. So this is going to be 3b plus 14. And then b minus 4 equals 0. So I just, factored that whole equation. And I get here that, again, if you want to solve for it, b is going to be negative 14 over 3. And here b is going to be 4. So I have two options. Either my base is negative 14 over 3, which makes absolutely no sense. Or the base is going to be 4. And lastly, let's just check if that works. So we said that the base is 4, and we were given that the height is going to be 2 meters longer than 3 times the base. And we were also given that the area was going to be 28. So if the base was 4, if I put 4 in for that b, I got that the height is 14. So what's the area of a triangle with base of 4 and height of 14? Well, that's going to be 4 times 7, that is, or 2 times 14. That's going to be 28. That checks out. Yay, winner, winner, chicken dinner. Alright guys, hope that helps.